Hello everyone, welcome to today's TechGoodReads. Today I will talk about how to use AWS Redshift efficiently. Redshift is the AWS data warehouse. It provides analytical capabilities to the large data. Here is the Redshift architecture. For the Redshift, it's an analytical massively parallel processing data warehouse. From the right side picture, we can see for Redshift, it has a ladder node and also a bunch of the computation nodes clusters. MPP provide a high read-write throughput and analytical capabilities. Another feature of the architecture is columnar data storage for analytical query performance. Due to the main purpose of the Redshift is used for analytical and also about structure. Although it has uniqueness, primary key, and foreign keys, but those constraints are informational only. There's no real constraints. To understand how the Redshift architecture impact its operation, let's think about this first question. Why we use copy command over insert when loading data into Redshift? Here we want to talk about parallel processing. Because that for the data warehouse is need to process a large quantity of data, so we want to make it high speed and thus we use parallel processing. For such architecture, there are mainly three solutions. The first is SMP. It means shared memory and I/O. The second solution is SDC. It means shared disk clusters. We can see right side of picture. Each node access the same storage. The third solution is massively parallel processing, MPP. It's shared nothing architecture. This means that in this solution, we can see that each processor has its own storage. And it only uses one message bus to coordinate between those different computation nodes. Since those nodes don't share any resources about the computational memory and disk, it can be highly effective for the read, write, and analytical tasks. For the copy, it's a Redshift command. It's used to load data in batch mode. We can use copy command, copy data from S3 into the Redshift. From the right side of picture, we can see that when we use copy command, the file in the S3, it will be split into small parts. And each small chunks, it will load into each computational node directly. This means that for the Redshift clusters, it has several nodes, and we also split big files into different batches and upload into those nodes in parallel. This is a very efficient way to load a large quantity of data into the Redshift. On the contrary, if you use insert command, it only loads one line of the data into one node. It cannot be paralleled. This means that using copy command is the most efficient method to load data. For the copy command, we can also custom the schemas. We can use JSON path file to define mapping when loading JSON files into Redshift. We can see the right side of picture when we want to use the copy command, and the command data, we want to do some conversion or maybe change the name field, and then we can use the mapping file to define what's the input and the target fields. Then copy command will use that mapping file to do the conversion for you. Here's the example about the JSON path. It looks pretty straightforward. Here, I also want to talk about Redshift query performance. When we want to improve query, sometimes we want to add some sort keys, and the sort key can help improve the query performance. There are two types of sort key. One is the compound sort key, one is interleaved sort key. For the compound sort key, we can see the right upper picture. If those two keys are queried one and then the other, we can use this compound sort key. For example, we always query by customer ID. All our query is query by customer ID and country ID. Then we use this compound sort key. It will split by the first sort key and then have the segregations by the second sort key. But if our requirement is that we want to query the data based on the customer ID, also other CQs based on the country ID, we need to use interleaved sort key. It's just group the customer ID and the country ID into smaller groups, and then it will improve the query both customer ID and the country ID. Of course, we can see that if we query customer ID, it will need to get more blocks to get the final results. So here we did a comparison. If there's no sort key, the performance is worse. Then interleaved sort key is better. Of course, if we want to get a high performance, we can use only one sort key. That would be better performance. If we want to evaluate those sort key performance, we can use SVL query summary table in the Redshift. It helps us to see how many number of the rows of a query has to scan over. We can see for an example that query for the no sort key, it needs to scan over 178 million. And if we use two interleaved sort key, it's scanned 10 million. If we use one sort key, it's only 484,000. From the Redshift, it uses columnar storage. Here, we want to answer how columnar DBMS improve analytical query efficiency. Let's see an example. We go to the supermarket and we want to buy a bag of the foods. And this bag of foods mixed with several kinds of foods. Such a bag of food is very good for the customer to pick up and to buy. On the other hand, we can also group the same food together. We just split into the different groups of foods. We can see those bananas, apples. They are easy to calculate, to be weighed, to get a price, but it's not good for transaction. So if we make them group them together, it's good for the analytical. So here we can see that for the transactional and the analytical, maybe different strategies we can use. So map to those foods, and we see that in the DBMS, there are mainly two types. One is row-oriented, the other is column-oriented. For the row-oriented, one object has a different kinds of data. Like here for the key, it can have the name, also zip, code, fin, age. They are of different data types. We will save them together at the same place. For the column-oriented, each column is stored in a separate file, and each column for a given row is at the same offset. We can see that for all the phone numbers, they are saved all together. Let's compare row-oriented solution and the column-oriented solution. For the serialization, for the row-oriented, it serializes each row into one place. For the column-oriented, it serializes all the values of a column together. For the row-oriented, the most efficient operation is return data for entire row. Also insert is provide a better performance. But for the column-oriented, it's good for the highly complex queries over all data, like get average, calculate, get sum. So on the contrary, for the non-efficient operations, for the row-oriented, it's not good at set-wide operations like range queries. And also for the column-oriented, is not good at retrieving all the data for a given object. Also not good at insert data because it's used several buckets to store data. When it's insert, it needs to split in and touch different storage. For the row-oriented, we want to improve performance. We need to use database indexes. It's just a small data set and only store one column, and we build that index, and this small column can be easily searched, and in this way, it can help improve performance. For the column-oriented, the good thing is that similar data is clustered together, and we can use compression to reduce the file size. And this really help improve the performance greatly. So we always suggest when you create a table, just choose the right compression method for each column. Due to those differences, for the row-based, the mainly use cases is for the online transaction processing. And for the column-oriented, it's used for the scenario of online analytical processing. Thank you for listening. This is Tony. See you next time.